All right, guys, let's start taking a look here. Normally, in a problem like this, it's very easy to find the sample. First question is, how did they pick their sample? What method did they use? Stratified. I love it, right? Because what they do, they broke the entire population of Ecuador into 3 groups. And then they took some from each group. Right? I can guarantee you there's more than 91 heavy wine drinkers in Ecuador. So stratified. This is my little answer key from yesterday's class. I gave out all my handouts. Groups and then some from all, right? That's definitely stratified. So the sample, start with the sample. What exactly is the sample in this problem?
The wine.
Say again?
The wine.
No, we're not sampling wine and then testing to see how much cork is in it or something, right?
We're sampling who don't drink wine, right?
More than that. You can be very specific.
91 heavy wine drinkers, 82 light wine drinkers, and 88 people who don't drink.
I love it. That's beautiful. How can you kind of condense that?
Add them all together.
261 Ecuadorians. Right? I'm really sure it's Ecuadorians, not
Would that be
Ecuadorians.
wrong on the test?
Huh?
Would that be wrong on the test?
No. So what you said is fine. It's just a little more detail than you need, but it still is the sample. The nice thing is, if you write 261 Ecuadorians, the population, if you write the sample some number of blanks, the population will almost always be replace the number with the word all. Because where did I pick those people from? All Ecuadorians. You with me? If my sample was 87 people from Wyoming that like to butter their toast, what was my population? All people from Wyoming that likes to butter their toast, right? That's the connection. Sample and population sound exactly the same. But one's talking about the population, the whole group, and the other one's talking about a subgroup. So that's all Ecuadorians for the population. I kind of gave it away with my circling up here, but what part of this tells you it's a statistic, the fact that part C here is talking about the sample. Don't say it's a statistic because it's a percentage. That doesn't. A parameter could be a percentage. That doesn't tell me why it's not a parameter. It's a statistic because it describes a sample. Bam. Sorry. All right. Everybody with me so far? I mean, it's that simple. If I would have said the researchers say that 3% of all Ecuadorians have stomach cancer, would that be a parameter or a statistic? Parameter, because I said all Ecuadorian, I'm describing the population. That's a parameter. Yeah, maybe. The greatest thing in math, parameter, population, statistics, sample. What level of measurement? Oh, I'm giving it away here. Shit. There's 2 answers for part A I would take, and that's why the explanation is so important. The most basic level, why do they give numbers out at a deli? To keep you in order. So you could say ordinal because that's how they keep the order, or because the number you get matters. Have you guys anybody ever been to Panera Bread? You get a number. Are the numbers in order? No, have you noticed that? You're 157. Next, okay, you're 3. Next, okay, you're 297. You know, the shit. So, but they still keep you in order, don't they? Because they keep track of those numbers. You with me? Okay. But the fact that a deli gives them out actually in numerical order too means there's another possible answer. So I would accept ordinal, but I would also accept interval. Because if you're holding number 7 and somebody else is holding number 4, you are 3 people behind. So the subtraction does tell you something that makes physical sense. I would accept either one of those answers based on your explanation. That's why if you leave the explanation blank, you lose over half the points because it's the most important thing. Now, I kind of gave this one away, but what is the, I try to give you a little bit, well, no, actually, on the test I will. On the test, I'll say identify the variable, what level of measurement is that? The level of measurement is related to the variable. What question did I ask? Or what did I look at for this problem? Blonde hair, brunette. What did I ask people? What did I look at? Their hair, in fact, I call this hair status because bald's not a color yet. Right? I either asked them or in case somebody's hair might have been different than what they were born with. What's your real hair color? First off. So it's not ratio because I see percentages. The percentages aren't the data. The data is hair color, and that's why it's nominal. It's hair status is what I call it. It's a category. You guys see that? So yeah, I'm evil. You knew that coming in. I'm a math teacher. We're inherently evil. I got an A+ in evil class. Kick ass on shit. So I will give you problems where I got like numbers related to what I did with the data. You just forget about the number. What's the data? Hair colors. Okay, nominal. Easy. Right. Because nominal does not mean number. It just means names. Not too far. Same thing down here. I gave you numbers. I gave you average stuff. That doesn't mean shit. On the first part, I'm looking at fish weights. Is that continuous or discrete?
Continuous.
Yeah, you don't say it's discrete because I see the number 2. No, stop it. It's continuous because fish weight varies. Not just varies. That's not. Don't say I weighed a week and the fish ate some, so it's heavier. But any individual fish could weigh anything between 0 and whatever. The biggest fish. You with me? So is it 2? No, it's probably 1.987469475 forever, right? Just had a little jazz moment. All right. You guys get that? So that is definitely continuous. It can take on any value in some interval. It kind of gives away what the next one is, but don't look at 2.3. Average could be anything. What is it they ask people? How many TVs you got? And that can only take on whole number values, right? You don't say you're bringing the TV in, so you got 2 TVs and I bought another one. Now I got 2.1, 2.2, 2.3, 2.4. It's not in the house yet. We don't have 3 yet. I don't know if you guys understand what I'm saying, but it's mostly for me because it was funny. You got a TV, you got another one. It goes up by 1. You can't go up by 0.0000000. What did we get today? We got another piece of the TV. Oh, 80,000 more mailings and we'll have a TV. No. All right. So that is definitely discrete because it skips values. It can only take on whole numbers in this case. That's how you can explain it. Maybe. Oh, and then the back here, let me just see. What do you guys, I think pretty much everybody got this. Even if this was 2.1, you round it up to 3. If you ever round down, remember the physical idea? Trying to cover? If you round down, you don't cover the whole thing. So if anything, you want to overcover. Then if you do it the textbook way, you see the width this way, not this way. And to be honest, when I go to do the picture, what is this going to start at? 62.5, and then it's going to go up to? So what is 62.5 to 65.5? That is 3. So in the textbook method, the width is hidden this way. Damn, textbook method. But you can use it if you want to. I mean, if you're crazy. I don't know. I didn't see many people doing the inequality method, but that would be 63 less than equal to x less than 66. Then you can see it both ways. Hopefully everybody got 310,964. Make sure it adds up to 32. That's a quick check. How do we know 32? Because it's 32. It's got to be 32 things, right? Is everybody cool with that? You guys all right? And then you divide that by the total to get relative frequency. And then you add them up as you go down to get cumulative frequency. And the people that didn't know this are the people that haven't done that homework yet. What the shit? Do the homework. But That's what cumulative frequency means, is you just accumulate as you go down. I got 9.4 so far. Plus this, so now I got 40.65, I guess. Plus this, now I got this much. Plus this, now I get this much. Blah, blah, blah. I don't want to play poker with any of you. I'm saying words, Jeff. Okay. And then finally, to put this thing together, I asked for a relative frequency histogram, so you got to make the scale based on your percentages. I went by 4 just to be different, because they had to go up to 32, because the largest percentage was 31, right? You could go by 5s up to 35, I don't care. There's nothing special about 4. Don't go by 1s. Here's my scale for this. Bam, 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 bam. Right, how can I double check everything's good? 3, 3, 3. See? I know there's supposed to be 3 wide. And then the height is just based on the percentage. Is everybody cool with that? Put the labels on there. RF for relative frequency. Father's heights is what I'm showing people. Way early. Bam. Next class must be really cool. All right. Any questions on all that? I mean, that's the kind of stuff I'm going to ask you on Thursday on the quiz. Okay. So, we need to continue moving along in chapter 2. Let's get into, should I stay up here? Yeah, sure. Let's try it out. See if I have any more paper. Yeah. Copy it. Kind of. No, not really. Oh, maybe a little bit. Okay. All right. Turn you guys on. So, we got into chapter 2. We did the histogram stuff. The very next thing we need to do is talk about something called percentiles. Sometimes on standardized tests, they will give you the result in terms of a percentile. Why would it not be fair? So SAT is not quite like this, but I think they do sometimes report percentiles. If you took the SAT one weekend and then the next weekend a friend of yours took the SAT, do they give you the same SAT every time? Does everybody know what the SAT is? Okay. Standardized test, it's evil, needs to go away, but I'll all still. All right. Every time they give it, they have to change it. Could they randomly change it so that there's more harder problems on the second go round? Then what would you expect for all the true grades? What would happen? They would all go down. So using just absolute grade would not be fair because the test changed. So what you want to do is compare it to all the grades for that specific test. So for example, if you made a 50 in biology, and a friend of yours was taking somebody else, and they made a 70, and they're like, I did better than you. They can't say that, because maybe their average was 80, and your average was 40. So your 50 was better than their 70. You guys see what I'm saying? They scored below average, you scored above average, right? So like my first graduate school test, did I ever tell you this? The teacher gave it back to me, I got a 21 out of 40. I'm like, what am I doing here? I'm in the wrong place. And the teacher's like, good job, Jeff. I'm like, are you being a dick right now? What's going on? But no, come to find out, the average was like an 18. They curved the hell out of the test, and they curved everything in grad school. Holy shit. You guys semi with me? So the idea of percentile is this. If you make a certain grade on a test, and let's say that 70% of all the other students scored below you, you were in the 70th percentile. Is that simple? Yes, that's a very simple idea. Let's see if I can make it come. So let me make up 10 numbers. Let me see if it's going to work on the overhead here. I don't really like to work on this too much, but let's see what happens. I'm going to make up 10 numbers. Jeff, let's go in order. That would be so nice. What do I got so far? 1, 2, 3, 4, 5, 6. Okay. Notice that I have them in order, which is a huge deal. If not in order, none of this makes sense. So there are 10 numbers up there, right? Did I get that? Yes, Jeff, good job. Does anyone have a guess for what the 80th percentile is? Based on what I just said.
48.
All right, I got a guess of 4. So we're trying to find what's called the 80th percentile. That's the symbol for it. Right? P80 is the symbol for 80th percentile. So I got a guess for 48. Why do you say 48?
I'm at 45.
Oh, shit. I got a guess for 45. Why do you say 45?
It's the 8.
It's the 8th number. Okay. I didn't say it was right. Anybody think it's 48? Yes.
Maybe because the 29's duplicates.
Don't worry about the duplicates.
Okay.
Yeah. So why would it be 48? What percentage is supposed to be below the answer? If it's in the 80th percentile, they're supposed to be 80% below it. Well, what's 80% of 10? 8. Which number has 8 data points below it? Right? But that's not even the right answer yet. Damn you, Jeff. If it's in the 80th percentile, what percentage is supposed to be above it? 20. Is there 20% above 48? No, there's 10%. There's 20% above 45 though, right? Now stay with me, stay with me. I love you guys. You're all like, so the right answer for the 80th percentile is the number between 45 and 48, because that's what does both of those things. Does that make sense? Yes. What's right between 45 and 48? 46.5. That's what P80 would be. So let's make this into a procedure. Actually, let's do this one first. What about P50? Let's do P50. Got no room for this shit, but what would P50 be? What do you think? It should be the one that's right in the... Does it make sense? 50th percentile should be right in the middle, but what's in the middle of 10 numbers? Yes, good. It's the number in the middle of the 2 in the middle. You guys with me a little bit?
35.
Okay, so P50 would be the average of 34 and 36, which is 35. Because it should be the number in the middle, and there's actually 2 in the middle. All right, now, so let's make this into a process. To find any percentile, let's say to find P80, there's 2 steps. The first step is where's the answer, and the second step is go get the answer. So the first step is I go 80% of the way into the list. How long was this list? 10. So please pay attention. Don't always use 10. I'm putting 10 because I had 10 numbers. Doesn't it make sense to find the thing that's 80% of the way in? I go 80% of the freaking way in. That's why that's the first step. And what's 80% of 10? 8. If this answer is a whole number, you average that with the next one. Isn't that exactly what we did up here? That was the 8th number, that was the 9th number. So if you do this and you get a whole number, you actually average that with the 9th. And when I average those, I do get 46.5. That's what P80 is. So let's try something more interesting. What about what is it, Jeff? 13. Yeah. What are the steps for P13? Try to do the first step. first steps. Bless you. Who is it? What? 13% of 10 is 1.3. Now, right, because how do you do the calculator? 13% of 10. 0.13, because that's what 13% is, times 10, because of means times. And I get 1.3. If you get, so is that a whole number? No, so I can't do what I did the first. If it's a whole number, I average that one with the next. Anything else, you force it up and take that number. So what's the next whole number up? 2. What's the second number? 28. So P13 is 28. Yes?
Wait, so the 10, so 13% of 10, 10 is just the number of numbers we have.
Beautiful. So if my list had 87 things,
So it would be
I would do 13% of 87. Please let that part make sense. If I want the number that has 13% below it, I'm going to go 13% of the way into the list. That is exactly matching with what I want it to do. This is what I mean by the more you understand the idea behind a process, the less you have to memorize it, and the more you just do it because it makes sense. Yes?
You always round up?
Yes.
So if you had like 2.1, you would go up to 3?
Yes. If you had 2.007. Oh, yes.
Can you re-explain how you got from 2 to 20?
6. So what? Sorry. What? Sorry.
Like, from, you got 1.3 and then went up to 2, and then how'd you get to 28?
So the first step is where is the answer? So what do we get? Second number is the answer. What's the second number?
28.
All right, done. Up here, we got a whole number. When we get a whole number, the answer is the average of the 8th and 9th. The 8th and 9th, I average them. So the first step is always, where is the answer? The second step is, go get the freaking answer. Because percentiles are called a measure of relative standard, or relative position. That's why it makes sense to use percentiles on a test I will give repeatedly, but it changes between each giving. Right? Because it would be really mean to try to compare, I took the really hard test and I didn't get in my college because my test was low, but so was everybody else's. That's not fair. Yes?
So if we're looking for 17%, it's only 28.
Yes. So why is this cool? Is this a very large set of data? No. That's why you're going to have a bunch of repeats because you have only so many data points. It's either a data point or it's between 2 data points, right? You see what I'm saying? So you only have so many possibilities. So P12 equals P13 equals P14 equals P15 because there's only so many possibilities. The textbook uses a slightly different method that is incredibly more complicated than it needs to be. For small sets of data, they don't have to be so specific because there's only so many data points. For large sets of data, this way matches with the book's way. Basically, the book's way is unnecessary. But again, if you want to do it the book way because you're copying stuff from the solution manual, okay, we'll stop doing that, but still, you can. Yes?
The one where we averaged 8 between like 8 and 9, and then between 8 and 9, we got a whole number 8, so why did we average it?
If you get a whole number, you average that with the next. Anything else, you round it up, take it up. That's the 2 things that can happen. So tell me, if I have 4 numbers, what's in the middle? What's half of 4? Is this the middle? Okay then, if I take half of 4, I get 2, I average that with the next one, and I do get the thing in the middle, don't I? That's why that makes sense. What's in the middle of 5? There is a number in the middle, isn't there? Well, what's half of 5? It's not a whole number, rounded up. The third one is in the middle. Yeah, it sure is. Right. And so the 5 and the 4 don't matter. It's you can kind of think of even and odd numbers, but don't even go. Yes?
So for this problem, anything above 1 to 2 would be 28?
Anything from like P11 to P19.
Would be 28.
Yeah.
P20?
Well,
It's a whole number.
P20 would be a whole number, you'd average it, yeah.
Okay.
I like it. And why does it make sense? There's only so many possibilities. So of course there's going to be a ton of repeats. Now if I had 80,000 data points, then every percentile could be a different number. Because now there's a bunch that go around, right? Maybe? Yes?
Question. For P80, why do you divide it by 2? It has to get that.
So remember, if you get an 8, you average that with the next, right? How do you average two numbers? Add them up and divide by. How do you average two numbers? Add them up, divide by 2. How do you average any set of numbers? You add them up, divide by how many there are. It's only going to be 2 because we're just averaging 2 numbers. Okay, I like it. Now, last thing for today. Don't get too excited. We're going to create what's called a box plot. It's actually called a box and whisker plot. My God, Jeff, what language is this? It's actually called a box and whisker plot, but for some reason the book likes to take all the fun out of it. So they call that a box plot. Once we create this, you will recognize it. Let's create it. So we make some other data up, just so we can have some another different number of data points. Let's see. Here we go. This is always exciting. Oh shit. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's make it 14. Yes. So those data points. Okay. Notice they are in order, because if they didn't have to be in order, I can make a percentile anything I want it to be, and then it means stuff. Okay, I like it, because I do give you stuff that's not in order, and I ask you percentile, you gotta put that damn thing in order. Okay. So let's do a very specific set of percentages. Even if you don't like football or basketball, how are those games broken up? They're broken up into quarters, right? So if I talk about the end of the first quarter, let's call that Q1. Is that cool? In fact, a lot of sports analysis call it Q1, quarter 1. What percentage of the game has been finished? 25%. So another way to reference P25 is Q1. They both mean the same thing. They both say the first quarter, right? How do I calculate P25? What are the two steps? 25% of 14, good, because now we got 14 data points. (14/4) is 7/2. What's 7 cut in half? There you go. See? Reducing fractions, you can do it in your head. 3.5, that's a decimal, so what do? Force it up to 4. What's the fourth number? Holy shit, we're done. Yay. Now you guys do the next two. Of course, the next two are going to be P50. Calculate that one, and P75. Calculate those two for me. So we're breaking the game up. Process doesn't change. You don't give a shit about whatever's going on. The percentage of how big my list is the first step.
We're still talking about the same set of data. Without thinking, all three of these things for that same set of data.
Where are we at?
percent is 0.5 of means times. Yeah, so I could have done 0.25 times 14, and it still says. But this just really says half of 14. Well, there's a point after the O, right? This is a whole 50, and you have to move it back twice to make it a decimal. So even if you do 0.5, right, now it's 0.5, right, times 14, you'll get the right answer. So remember, 50% is just half. You know half is 14. Second. No, it's half of 14. It's half. You don't do 50 divided. Of means multiple. 0.5. That's where 50% is. Times 40. Or 50% of something is half. Yes. That's what very often you get so in the math, it has to make physical sense. So you always have another way to look at it.
I got 30.
So 11th number.
For that, it's 50%. That's.
Yeah, average that with the next
That's
one.
the whole number, so you have to find average.
Yeah.
So, to find the average, you have to go 4 in, 7,
Bottom
and 8.
Q3, you go 4 in.
Mine's not bad, it makes 7, 8 pounds,
So if you get 7, it's a whole number. You have to average that with the 8th number. So it's the only two things that could possibly happen.
Right, okay.
Yes, yes, good.
Yeah.
All right. So let's see. So this one you take half of 14, and you get 7. What does it mean when you get 7? It's a whole number, so you have to 7th and 8th average. And what's the average of the 7th and 8th numbers? 30, right? Is that right?
Yeah.
Q3, 75% of 14.